Da, păi te introduci tu, nu știu. Eu nu sunt mare, la cum e vornic?
MC?
MC, da. Da, nu sunt mare MC, da.
Bun, o să vorbesc în engleză, că sunt mai obișnuit cu subiectul ăsta în engleză. Eu sunt Bogdan, vorbesc cu Python de 10 ani. So, hi, my name is Bogdan. I'm here to talk about Dramatiq, which is a distributed task processing library for Python 3. Let's define some of those terms. Distributed, just basically it means you can run it on multiple machines that are networked. Task processing, it means you can run arbitrary workloads across those machines over the network. And it's a library, Python 3. Here's what this generally looks like. You have your producers on the left. Your producers can be anything from a user interacting with your web app or your mobile app, or some automated cron job, or I don't know, some arbitrary script that someone's running on their machine or wherever. All of those are able to send messages over the network to a message broker. Those messages describe the work that should be done. And the broker takes care of distributing those messages to any number of workers. The broker in this case is RabbitMQ, but Dramatiq also supports Redis, and you can write your own. And the workers, when they get one of these messages from the broker, they'll try and do the work. If, I don't know, if something fails, if there's a non-handled exception, then the message gets sent back to the broker. The broker will send it later to some other worker so it gets retried. If the worker fails, or if it crashes, or if there's a network failure, anything like that, while it's processing a message, it will, again, the broker will actually figure this out and resend that message. So message delivery in Dramatiq has at least once semantics, which means your tasks have to be idempotent. So use cases for something like this include anything that needs to run outside of the request response cycle, asynchronous tasks, anything that may need to be retried on failure. So say you're talking to an external API that you have no control over, that might fail. You might want to retry that stuff. Background queries, number crunching, lots of stuff. Long-running actions, periodic tasks. So if you're familiar with the space, you might be wondering why a new library, and specifically why not Celery? That's a fair question. I wrote Dramatiq because I grew frustrated with Celery's deficiencies, having used it for many years. Specifically, the things I'm looking for in a library like this are high reliability out of the box, high reliability. Like I said, Dramatiq has at least one semantics out of the box. Celery has at most once. You can configure it to have at least one semantics. It's just a little bit of a pain. I like having good defaults. Next one is high performance, by which I'm mainly referring to throughput. So these libraries shouldn't get in your way. Neither Celery nor Dramatiq do. They're both extremely fast for Python. And I wanted it to have a simple core implementation, which if any of you have looked at Celery source code, I feel like you might appreciate this. And one thing I prefer, having used systems like Sidekick, Ruby, or Google App Engine, I like conventional configuration. Celery has hundreds of knobs that you can tune, which is, you know, in some cases it's a plus, but I subscribe to the adage of, you know, constraints liberate, liberties constrain, and yeah, I think when you have a well understood constrained system, you're able to produce better stuff, just because your mental model is a lot simpler. And Celery didn't cut it for me. So here's a little feature comparison I did. These are, in my mind, some of the most important things, or some of the most important differences between Dramatiq and Celery. Number one on that list is Dramatiq doesn't support Python 2. If you're stuck on Python 2, I'm sorry. That's very sad. It's dying in 2.5 years, so clock's ticking. But if you have to use Python 2, then it's not for you. A big thing I want in one of these libraries is the ability for my workers to automatically reload when my code changes. So this is a big deal when I'm writing code. Celery had this feature in version 3. It never really worked reliably, so they removed it in version 4. This is why I fixed it. Another one is locks and rate limiting. You could say Celery has rate limiting, and by locks and rate limiting I mean global distributed locks and rate limiting. Celery has per worker rate limits, and in an auto-scaled environment, this doesn't really cut it, because if at any moment you don't really know how many worker processes you have, then per worker rate limits are just, they're not very useful to you. Another big one is queue priorities. If you have workloads that may block the UI for a user, and workloads that don't and are maybe less important, then being able to prioritize queues between each other is kind of an important feature. Again, Celery has support for prioritizing messages within a queue, but that's not quite the same thing. And RQ, oh yeah, I added RQ in just because it's another popular choice. I don't personally think you should use RQ for anything that's non-trivial, but it's there if you want it. That said, RQ does have queue priorities by way of, you actually specify, when you run your workers, you specify a list of queues in order, and it grabs messages from each queue in that order. That's kind of a pain in the ass for ops, but
so we're talking about the queue message priorities.
Message what?
The message, like you have the key message that you put in the queue, in the header, it can have a priority field.
Yeah.
So that's what we're talking about.
Well, sort of. That's what Celery does. And if you're using RabbitMQ, for example, then that'll prioritize the messages within that queue, right? So if you're using one queue, then yeah, that works. So any message you send to that queue, the ones that have higher priority will just get put in the front of everything else. Now the problem is if you have multiple queues, Celery has no way of dealing with that, because the messages are always prioritized within those queues. So it just doesn't.
Okay, well, technically Celery doesn't allow you to set the priority on RabbitMQ. It only supports it for Beanstalk or something.
No, they added queue priorities in version 4, or message priorities.
Oh.
So yeah, it's there. It's not as good as it should be. Then the one I've talked about before, simple implementation. I'd argue RQ is also pretty simple, although it seems to me it's larger than it should be. Celery definitely isn't. It's spread across 3 projects basically, and it does a shit ton of magic. Like you would not believe the things it does. And then both Dramatiq and Celery have support for delayed tasks. I'd argue Celery's support is pretty broken, or at least it's not intended for high volume delayed tasks. So what I mean by that is when you've got a delayed, all delayed messages in Celery are put on the same queue as normal messages. And then the workers actually have to pull all of those delayed messages into memory and then wait to execute them. Now the problem is because you have all these messages on the same queue and because they're all, because you're constrained by memory, obviously your workers don't have infinite memory. It has to have a limit to the number of messages it can pull. If you have many messages that are delayed far into the future, this can deadlock your worker, at least until those messages are ready to run. Any new non-delayed messages won't run, which I've had that happen to me in production, and it's not particularly fun. Dramatiq solves this by having separate queues for delayed messages, pulling them into memory, and then re-enqueuing them on the actual normal queue when they're ready to run. As far as I know, RQ doesn't have anything like that. All 3 of them have result storage. I would say Celery's is the best here. Well, not necessarily the best, but the most featureful. If you use things like chords and groups, that gets sort of into more advanced territory. Dramatiq doesn't have an equivalent of that, but you could build it using its middleware functionality. The problem is that stuff in Celery I found to be quite flaky, again, at scale. Another big thing, automatic retries. You could build this into Celery by using signals. Dramatiq just retries your tasks by default whenever they fail. It'll use exponential backoff. It'll retry them up to about 30 days, at which point, if you don't fix the problem until then, the task will get put into a dead letter queue where it's kept for another 14 days, so you can look at it if you want to. If you don't, it'll just get expired.
So the retry will use the delay feature, right?
Yeah, exactly. 2 major downsides with Dramatiq are the fact that it's so much newer. I've only really started working on it in, I think, March of this year. Started showing it to people a couple months ago. So there's a much smaller community around it. It's probably also a lot less familiar to all of you. And then another one I've talked about before is high throughput. Both Celery and Dramatiq are very fast for Python. Dramatiq is slightly faster, which I'm pretty happy about. Let's see. So to get started, you can just install it from PyPI. I would recommend using pipenv. If you haven't heard of it, Google it. It's pretty great. It's from Kenneth Reed's, the guy who made requests. So you just install Dramatiq with support for RabbitMQ and watching for source changes. You can switch RabbitMQ for Redis if you like. So if you want to use Redis as your broker, that's all you would do, and then configure it a little bit differently. But this is the basic pattern. All actors in Celery are just normal Python functions. You decorate them with this Dramatiq actor function. And then you get to call them like any other function. Where it gets interesting is when you start running workers. So let's say we're running RabbitMQ. You get to be able to send the actor a message. So this will enqueue a message using RabbitMQ, give you a representation of that message, and then if you run your workers, I'll explain this in a second. If you run your workers, you can see it actually eventually picks up the message, runs it, prints out the output, and then just tells you it's completed. The reason I'm passing this Python path environment variable, and I might change this in the future, is by default it doesn't add the current working directly to your import path. You get to just specify it using this. That's just a standard Python function, standard Python functionality. And yeah, so I prepared a little demo app just to show you how you could use this with a little small, dumb Django app. And its data model looks a bit like this. You have products. Each product has 0 or more SKUs. Each user has a cart, and every cart has 0 or more cart items, and SKUs map 1 to 1. That's perfect. So let me just show it to you guys in action. It's called Guilt. I don't know if any of you are familiar with guilt.com. That's where the name comes from. It's kind of a stupid pun. But yeah, you get to like add stuff to your cart, and you get to remove it. That's all well and good. But then the problem is, let me switch back to my slides. On checkout, we have to do 3 things. We have to clear the user's cart and mark all the SKUs as sold. Tell an external warehousing system to prepare the products. And this is the main issue here. The warehousing system is legacy, it's busted, it's slow and failure prone. It fails about 30% of the time. I'll show you why in a second. And then finally, it has to send the user an email congratulating him or her on the purchase. So let me switch the code real quick. Let's see. Let's look at the warehousing system first, or actually, let's see, views. So this is what the checkout view looks like. So within a transaction, it gets the cart, it tries to mark all the SKUs as sold, and then deletes every item. And then, sure. Is that better?
Yeah.
And then finally, it calls this warehouse prepare method, and then it congratulates the user on purchasing stuff. Let's see. And like I said, the warehouse is slow and error prone, and this is kind of a convoluted example, but it's a demo. So for every SKU you give it, it'll sleep for 1 second, and then about 30% of the time, it'll fail. And so if I'm a user using this app, I get a pretty poor experience. Check out now, you can see it takes quite a while, and it might fail. I'm hoping you can see it fail. But okay, it didn't fail. Let's try again. There we go. So now as a user, I'm pretty pissed off. I might abandon this cart, might do other stuff, might go to support. If I come back here, I can try again. But here's how you could potentially use Dramatiq to fix this. So I'm just going to come in here, I'm going to import Dramatiq and declare 2 tasks. Let's enter. This is going to be prepare SKUs. It's going to take a list of SKUs, and then it's just going to call the warehouse exactly like we are in the view. And then I'll do the same thing for the email. I won't even show the email method because it's so simple, but it's just a stub like the warehouse. And then rather than call these things directly, I'm just going to use Dramatiq to enqueue them and have them run in the background. Because if you think about it, there's no really, at this point, there's no reason for the user to wait for this stuff. Like, he shouldn't have to wait for the request at the warehouse or to get the email. He can get those later, and his experience will be affected by this. So now, if I use my tasks, let's see, to import them first. Tasks. So I've just replaced those two calls. You can see I'm still doing these inside a transaction because I don't like if these network requests, because these are going over the network to RabbitMQ, they could still fail. There's still a chance. It's less likely, I would say, than talking to an external system, but it can happen, and it does happen. So let's see, so I've done this, and now my server is down. That was weird. Well, that's the live demos for you. Go. Sorry about that. So now, if I hit checkout, you can see it's instantaneous. And the caveat is I now have to run that, execute that work somewhere. So I'm just going to spin up a couple of Dramatiq workers here. And you can see it's actually doing the work. And the warehouse system was down, luckily, and it's retrying that call. It's going to retry.
Is it a mixture of processes and threads?
Yeah, yeah. So by default, it spawns as many processes as you have CPUs, and then 8 threads per process. And then you can control that if you don't want.
Okay, but the defaults.
Yeah. So you can see the process IDs all here, and then yeah.
What about so when sending the message, how do you specify the priority?
The priority, you actually specify it on the actor. So that would look something like this, priority 10.
So I cannot have it per...
You couldn't have it per message, not right now. Well, you can do it, I wouldn't do it right now. It's not gonna pick it up right now. So you can, when you send a message, for example, I can do tasks, prepare SKUs, send with options in here, and then I can send. This is sort of this is the equivalent of apply async in Celery. So I can send it like SKUs, and then I can say options is a dictionary, and then I can specify the priority in here. But right now it won't get picked up.
Why not?
It's not implemented yet.
Would it be?
Maybe. I'm not sure about. Like, can you give a use case? Like, I prefer having the priority statically defined.
PIP accounts.
Oh,
You want those customers to like.
Well, then you could just use it. You could
order
just.
processing.
You could use a separate task, or you could use something like. There's the concept of class-based tasks in here, so you could use inheritance or something like that.
But would you accept such a change?
Yeah.
Okay. Okay, another question. So it seems a bit wrong to congratulate on the purchase before preparing queues. Let's just suppose that there's an earthquake and the warehouse is all trashed out, and there's no products. And I mean, what's the point of doing the congratulation here? The warehouse.
So you're getting at callbacks, right? You wanna send a message on
the chain
success.
of
Right. You can do that with middleware. So you can write a little. Probably not going to be able to do it live right here, but you can basically do something like a callback middleware, and then there's a after process message hook, and you can use that.
How do you set the middleware on the actor?
You don't set it on the actor. You can just you set it on your broker. So in this case, I would do something like get broker.
You need to check for which is the actor.
Yeah. You could do it via options, right? So you could, middleware are able to add options to actors. And so when I write my middleware, I could say something like on success here. Or I could, and this would actually work, so I could reuse send with options and set that as an option here. Does that make sense? So something like that would be pretty easy to do, but it's not built in, right? And I guess the last thing I wanted to show was you might want to, and this isn't something I would necessarily do using tasks, but it's a decent example of delaying tasks. So say you're one of those e-commerce websites that has flash sales. You might want to, after the product has been in the user's cart for say 10 minutes, you might want to remove it just because they're not really doing much with it. So to do that with Dramatiq, we could add another task in here, call it expire SKU or expire item. It's going to take an item's primary key. It's going to load the item. It's going to unreserve serve the SKU, and then finally it's going to delete the item. Probably want to do this in transaction. And then whenever we add an item to the cart, we can just call this task and queue it to run later. So in this case, expire item, send with options, item primary key, and then delay is going to be, I'm just going to do 10 seconds right now because I don't think any of us want to wait 10 minutes. It's wrong name, tasks, and let's see. So now if I add this to my cart, I should eventually see it run over here. There we go. It expired my item. If I go back to the website, it's no longer there. You would probably be better served by cron for something like this, but it's there. So yeah, that's all I got. Any questions, comments, concerns?
What if we have any dependencies between tasks? How do you handle that?
So that's similar to what Yonel was asking. You would define something like an on callback or on success callback using middleware. I can try and do it right here, but it might not end up too well.
Is it running on production on the site right now?
It's going to go into production at my current employer next week. It'll be a fairly not small, but middle-sized service that's going to go into production. And there are integrations for Django, which you just saw. So that's able, you can just use manage.py to run all your workers. There's an integration for API star, and there's a way to use it with Flask. Again, you need to declare one of these middlewares. And that's the main point of
so in Django, that's the transaction stuff.
Yep, exactly. Yeah, there's just a middleware to close the DB connections when any thread stops. And there's, I forgot to show this, but this is kind of cool. If you're used to, let's see, if you're used to Google App Engine, I don't know how many of you have used it. You have. So you know there's a little GUI in there. I don't have a super user. Let's see. Whoops. Sure. One, two. I'll just. No. Wow, that's awful. Okay, there we go. All right, so there's also this little middleware that doesn't seem to work right now, which is sad. But basically, you can see tasks in progress using this via the Django admin, and you will be able to retry them and stuff like that. I have no idea why that didn't work.
Does that connect to the result backend, or
that's
monitoring?
It uses middleware to store Django models, basically. So it doesn't use the
monitoring.
Yeah, basically.
Can you stop running tasks or filter them or stop
you can't stop running tasks, but there is functionality built in for adding time limits to tasks. So the workers are able to kill tasks that run for too long. There are some limitations there. So in Python, you can't kill any thread that doesn't own the GIL, which means that if the thread is blocked doing a system call,
you can't stop it?
No, there's nothing you can do. You can kill the process.
Same things happen in Celery.
Yeah. It's a limitation of Python. You can't really do anything about that. If you use threads.
So,
go ahead.
So how does the result storage work? Can you query any task? Has it run? Has it not run? Is it run?
No. It's very simple. It's just literally based on. Again, let me show you the docs for middleware. Oh, and I forgot to mention the docs are kind of great, but I wrote them, so your mileage may vary. Let's see. So essentially, the result backend is implemented as a middleware as well. When after a message is processed, it just stores the result to either MessageC or Redis right now.
So if you'd want to do things like progress reporting from inside a task, you'd have to do it.
You'd have to write one of these. Yeah. Any other questions? Going once, twice. All right.
Plans for the future?
Right now, I want to use it in production some more, just to, see what could go wrong. But mostly, it's for the stuff I've used it so far. It's been pretty good. I don't really have any huge features in mind right now. There's one open issue right now about. So all of these, I forgot to mention, all of these messages are encoded as JSON before they're sent to the broker. There isn't a way to change the encoding type, and there probably won't be, at least for the foreseeable future.
Not even compression?
Compression, I might add compression, but I don't, Celery 3 uses pickling by default, which is kind of insane. RQ, they stopped in 4, yeah. And then RQ also uses pickling, and I don't want people to use pickling.
Pickle is fast.
It's also super insecure.
Well,
I mean, it depends. Let's see. There is an issue open for someone wants to add support for encoding hooks, so they can transform their messages, their you know, the objects they put in messages before they're sent. So like, if you send a date time right now, it'll just crash because it doesn't know how to encode date times. So I'll probably add that because that seems pretty useful. Like if you have UUIDs or date times or whatever.
Yeah, I mean, no, not everyone needs security.
They have a lot of contributors.
So far, let's see. There's a list of them on GitHub. I think there have been 4 so far, or three besides me. Let's see, contributors. Yeah, there have been 3 others so far.
Did anyone try to contribute to people support? Yeah.
No.
No?
No,
Did
it'll
you
probably
accept it?
no.
No?
No, it'll probably get rejected.
Really? Come on. At least middleware or something to support. How hard would it be to support these?
To support
outside.
pickling?
Yeah.
Right now, it wouldn't be hard. You would have to change up the way the message class is structured, and that's a fairly simple class. It's like 50 lines of code.
So you would make it pluggable?
Yeah, essentially. And yeah, there's a lot of examples in here. I don't know. I would urge you to look at the code. I'm pretty proud of how it's structured and how small it is for all it does. It all kind of assumes Python 3.5, so anything below that won't work. And in fact, I tried to support Python 3.4. I ended up opening an issue with CPython because in order to be able to interrupt running tasks after a timeout, what it does is it sets a signal on the process, and that triggers every second. I forget what the system call is. It's like set iTimer or something. The problem is, in versions prior to Python 3.5, those kinds of signals will actually interrupt stuff like time.sleep or pretty much any Python function running on the main thread.
It
So
doesn't have the automatic withdrawal of syscalls, yeah.
Yep. So that's kind of a big deal. But yeah, and it uses Pika internally, so it's all pure Python, which means you can use gevent with it pretty easily. In fact, that comes with the package. You just run Dramatiq gevent instead of Dramatiq, and that's for some workloads that can be pretty impressively faster. Yeah.
How customizable is it? Can you set options for tasks like timeouts, whether to store the result or?
Yep. So you would, let's see. It's basically the same mechanism here. So I would set a time limit here, and it's all in milliseconds, sort of arbitrarily, but I prefer milliseconds. So that's all you would do, and this task can run for 60 seconds. By default, it'll let tasks run for 5 minutes, or no, 30 minutes, sorry. One thing I forgot to mention, for those of you who are more ops-minded, there's a built-in Prometheus middleware. And so your workers are automatically going to expose task metrics that you can look up using Prometheus. Let's see if I zoom out here. In the cookbook, there's advanced topics. So it exposes a bunch of Prometheus metrics that you can look at and monitor on, and then you can use something like Grafana to actually view those messages. And that's all out of the box. It's kind of something that is severely lacking from Celery, in my opinion. If you want to use Prometheus with Celery, it gets complicated because multi-process Prometheus in Python is kind of crappy, but also because Celery imports your modules before it forks. And it does that to conserve memory. But if you have any, code that you want to run on each process, that's sort of a problem. Dramatiq doesn't do that, so Dramatiq will actually use more memory when you run it in multi-process mode. But it also makes this kind of stuff a lot easier.
You also mentioned that it assumes that all tasks should be idempotent. I assume you can change that behavior.
Yeah, you can tell it not to retry. And you can tell it how many times to retry. You can tell it, by default, it has this simple exponential backoff function that it uses. You can't change the function right now, but you can tell it what the backoff factor should be. That kind of stuff. That's all, again, that's all pretty well documented on. Let's see. And all of this functionality is implemented using middleware. So you can even take it out if you don't want retries at all. You can just take the middleware out and it won't do anything. Just same with Prometheus. And so retries. Yeah, here's what the middleware looks like. And then these are the options you can set. You can set these both at the actor level when you actually. You can also set them when you send with options.
Other questions?